Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 Section 6.3. Today we're going to go over something called the Mandarin Gauss Elimination Method. This is for solving systems of equations. Now, why do we have it called the Mandarin and Gauss Elimination Method? So before we go into our lesson, we're actually going to have a mini history lesson. There was a gentleman named Friedrich Gauss a long time ago. And Gauss was a brilliant mathematician. He was around from 1775 until the mid-1800s. 1855 is when I believe he passed away. And he created something called the Elimination Method for systems of equations. The problem was that about 500 years earlier, there was a little Chinese gentleman whose name is pretty impronounceable, but I'll try it, in Qin Jiushao. Qin, Q-I-N, Jiushao, Jiushao. And he was around in 1247 when he wrote his mathematical treatise in 9 sections, which included the elimination method. So while some people call this Gaussian elimination, I prefer to call it Mandarin Gauss elimination because it was invented by a Mandarin about 500 years before Gauss created it. So let's go ahead and jump into the meat and potatoes of this lesson. So the Mandarin Gauss elimination method is a method of finding where two lines intersect, or actually a system of equations intersects, using something called elimination. We make a variable go poof, and then things become nice. So let's go ahead and look at a simple example. Let's look at the system of equations. X minus 2y is equal to negative 19, and 5x plus 2y is equal to 1. Now, you'll note that I tried my best to line up the x's and the y's. This is a really good habit to get into if you're going to be using the elimination method. The reason being is that we want to eliminate every piece in its row. For an example, I'll note that my top row, or my top equation, which I'm going to call row 1, my pen will write, and my second row will call, well, I guess row 2. In row 1, I have a negative 2 in front of my y. In row 2, I have a positive 2 in front of my y. So if I was to add these two rows together, my y's would go poof. They would eliminate each other. And I would be left with 6x plus no y's is equal to negative 18. I have eliminated the y's. They no longer exist in our functions. So we end up with 6x has to be equal to negative 18, which means that x is going to be negative 3. To find the y, of course, we use the substitution method. We plug that negative 3 back into one of the equations. I'm going to use row 1's equation just because the x is by itself, and so it should be easier. So we have negative 3 minus 2y is equal to negative 19, which means that we have negative 2y is equal to negative 16, which means that we have y is equal to positive 8. So the answer to this system of equations would be at the location negative 3, 8. Now the beautiful thing about solving a system of equations using the elimination method is substitutions, especially when you get into larger systems of equations, become really hard to work with because there's just so many things that you have to sub for, and you have to do it over and over again, and anytime you make even the tiniest of mistakes, it will throw everything off by a long shot. While with the elimination method, it's a lot more concise, it's a lot easier to work with, and so that's one of the reasons why I really like the elimination method. Not to mention, it's so easy, even your calculator can do it. So let's look at another one where it's not so cut and dry, so that we can learn some of the rules about the elimination method. All right, let's look at the equation 3x plus 4y is equal to 18. And the other equation negative 2x plus 4y they don't go poof. So I have to make them go poof. That's right, I have to make them. The way I do it is I'm looking at my coefficients. The coefficients are the numbers that you multiply your variable or letter by. So looking here, I have 3 and negative 2. Those would be really hard to make look exactly the same, but with opposite signs. Now over here, I have 4y and 4y. Oh, that should be a lot easier to manipulate. So what I'm going to do is I'm going to take my second row and I'm going to multiply both sides of my second row by negative 1. When I do that, I rewrite my equations as 3x plus 4y is equal to 18. That one didn't change. But now my second row has. It's turned into positive 2x minus 4y is equal to negative 8. Now if I look at it, the coefficients in front of the y are the same number, but opposite signs, which means that if I added them together, they would cancel each other out. They would eliminate each other. So that's exactly what I do on my next line. I add the two equations together, and I eliminate my y's. 3 plus 2 is 5. 4 plus negative 4 is 0. And 18 plus negative 8 is positive 10. Leaving me with 5x is equal to 10. I can then divide both sides by 5, and I get x is equal to 2. Once again, all systems of equations are solved or answered with a ordered pair, which means that we need more than just the x, we need the y as well. So I'd plug it into one of the equations. Looking at the two, I don't like doing negative numbers, so I'm going to go with the first line, or first row. So I'd say 3x plus 4y is equal to 18. My x is 2, so this becomes 3 times 2 plus 4y is equal to 18. 3 times 2 is 6. Subtract 6 from both sides. I now have 4y is equal to 12, which means that y is equal to 3, which gives me the ordered pair 2, 3. So 2, 3 would be the intersection of the two lines, or the solution for this system of equations. Which brings me to the next point. What are the rules of the elimination method? What are we allowed to do? What are we not allowed to do? So here's rule number 1. Rule number 1. You may multiply a row by a number. Meaning, if we look in our two examples, on our second example, I multiplied my second row by negative 1. So I can multiply a row by a number. Can I multiply an individual piece by a number? No. I have to multiply the whole thing. The whole enchilada, the whole watermelon, all of it by that same number. Then, rule number 2. You may add rows. In both examples, got to get plural there. In both examples, I ended by eliminating a variable by adding one row to the other. That's my second rule. I'm allowed to add rows together, and I am allowed to multiply a row by a number. That's it. That's all I'm allowed to do. Can't do anything else other than the normal rules of algebra. So for the elimination method, you may multiply a row by a number, and you may add rows. So let's look at an example where things aren't so nice. It happens quite often. Actually, it happens more often than not. Let's say that we are given the system of equations. 2x plus y is equal to 3. 2x plus y is equal to 3. And the other one is negative x plus 3y is equal to 12. Negative 12. So negative x plus 3y is equal to negative 12. Again, I want to use the elimination method because, to be honest, the elimination method is probably the best one out there. The problem is, who do I eliminate? Well, I would normally say the y's because, hey, the y has a positive 1 in front of it, but the other one has a 3, and 3's are notorious for being mean. They don't like playing with even things. They're quite odd, if you ask me. Which means that maybe I would want to eliminate my x, because, hey, who doesn't want to eliminate their x? Well, unfortunately, in this case, we've got the same problem going on. We have to multiply a row. So looking at the 2, to be honest, I think going with the x's would be easier, but not by very much. So I'm going to go ahead and multiply my second row by 2. Now I know this is going to make my constant much larger because I'm having to multiply my larger constant by a number. But I think we can handle it. I think it's still small enough that we can figure out a way to make things work. When I do that, my new system looks like 2x plus y is equal to 3. Note the first row does not change at all. And the second row becomes negative 2x plus 6y is equal to negative 24. Now I know that when I add them, my x's will eliminate and I'll be left with just y. So I add them together and I get 2 plus negative 2 is 0. 1 plus 6 is 7. And then negative 24 plus 3, or 3 plus negative 24 is negative 21. Meaning I really have 7y is equal to negative 21. Divide both sides by 7, I have y is equal to negative 3. But I'm not done yet, I still have to find my x value. So I plug it into my first equation. My first equation was 2x plus y is equal to 3. I then plug in y is equal to negative 3. So I have 2x plus negative 3 is equal to 3. Add 3 to both sides. We have 2x is equal to 6. Divide both sides by 2. We have x is equal to 3. Oh, not done. So I have a y-coordinate at negative 3. I have an x-coordinate at 3, which means the solution would be at 3, comma, negative 3. Okay, elimination method, not too difficult. We can handle it. It's not so hard that we want to rip our hair out or hard enough to make our hair turn gray. It's simple stuff. Follow the 2 rules and everything will be fine. But I know what you're thinking. Mr. O'Neill, Mr. O'Neill, Mr. O'Neill, what about fractions? We hate fractions. We can't do things with fractions. And I say, au contraire, it's quite easy to do things with fractions. And I will prove it to you. Let's look at a system of equations that has some interesting fractions. Let's say that we have 3/2 x minus 2/3 y is equal to 12. And we're going to have another system of equations of, 3x minus 5y is equal to 15. And we want to figure out what x and y are. Well, to do that, we're going to use the elimination method. Now, if you remember, we can always multiply a row by a number. And I know how much you guys love fractions. I know that you write poetry to them and buy them flowers, bring them chocolates. Okay, I know you hate fractions. It's all right. Most people do. So what we can do is we can, eliminate the fractions. To eliminate fractions, you multiply by their common denominator. or I should say least common multiple denominator. We have 2, which is prime and even, which makes it the oddest prime of all, and then we have 3, which is just plain odd. So let's multiply 2 and 3, and we get 6. So I'm going to multiply this top row by 6. When I multiply the top row by 6, I get 3x minus, 6 divided by 2 is 3. 3 times 3 is 9. 6 divided by 3 is 2. 2 times 2 is 4. And then 6 times 12 is 72. My bottom row, of course, remains unchanged. Now looking at these, I think the numbers are not going to work out quite nicely, but that's all right. We'll find a way to make it work. Let's see, which one's easier to eliminate? The x's or the y's? Well, looking at them, 4 and 5, the closest or the smallest common multiple of those two is 20. And that's kind of large, because then I'd be having to multiply my top row by 5, and that 72 is going to get huge fast. I don't want to do that. But looking at the x's, 3 times 3 gives me 9, which means that I wouldn't have to multiply that first row at all. I think I'm going to try to eliminate the x's. All right, so to eliminate the x's, I would multiply my second row by -3. And when I do that, it gives me the system of equations. 9x minus 4y is equal to 72. And it also gives me -9x plus 15y is equal to 45. -45. Now this is a beautiful thing, because when we add them together, our x's will eliminate. So I'll put it in pink to show how beautiful it is. All right, 9 minus 9 is 0, so gone, bye-bye, no more x's. -4 plus 15 is 11. And 72 minus 45, ooh, that one's a tough one. Let's see, 6, and then that would be 12. That would give me 7 and 2, 27. Another way to do it would be to say, okay, how far away from 72 is 45? So 45 to 50 is 5, and that puts me at 50. And then to get to 72 is 12, or 22. From 50 to 72 is 22, or you can say from 50 to 70 is 20, and then from 20 to 22, or to 72 is another 2, so that would be 5 plus 20 plus 2, which would be 27, so it's 27 units away. That means 72 minus 45 would be 27. A lot of the times that way is easier, especially if you have carries, but hey, it's a different way of doing math. Just look at how far you're going and just go one step at a time. So we have 11y is equal to 27, which means that y is going to be, you guessed it, a fraction. Which, of course, we love fractions, so I'll put hearts around it. All right, our fraction answer of y is 27 over 11. Don't put it in decimal form. Decimals lie, so let's not use that. Once we have our y value, we plug it back in and find our x. And considering that we really don't like fractions, let's go ahead and use the second equation for plugging it back in. So we're going to have 3x minus 5y. Well, y is 27 over 11, so let's put that down. 27 over 11 is equal to 15. I know you guys don't like fractions, so let's go ahead and multiply everything by 11 first. So we have 33x minus 5 times 27 is equal to 15 times 11. Multiplying together, 165. And then we take 5 times 27. Okay, so 5 times 27 shouldn't be too hard to do. 35, 5, 6, 7, or 10 plus 3 is 13, 135. So this becomes 33x minus 135 is equal to 165. Now we add 135 to both sides. And that gives us 33x is equal to, that's a 0, carry the 1, that's a 0, carry, 300. Almost perfect. So x is equal to 300 over 33, which reduces to 100 over 11. So x equals 100 over 11. We have our x, we have our y, we have our ordered pair. Our ordered pair is 100 over 11, comma, 27 over 11. And we are all done. And note, no calculator necessary. Look at that. Can do math by hand. Who figured? Anyway, that is it for today's lesson. Let's go ahead and get into the before you go work. All right, so here's the bug work. Your bug work for today is going to be a lot. It's going to be section 6.3. Yeah, this is 6.3. Hashtags, math is awesome. Fractions are friends. Gotta eliminate them all. And of course, Gauss is 500 years late to the Qin Ju Xiao party. Here we go. All right, so we're going to go 1 through 9, odd. And because I love you so much, a whole bunch of extras. Let's go with 15 and 19. And 23. And that's it. Yeah, that's it. Whole lot of stuff. All right, there you go. Good luck and have fun.